So d prime of 120, we know prime is referred to derivative, but another word for derivative is slope, because it says estimates, right? We don't know the exact slope at 120, but we can, the closest we can get is using order pairs that's close to our point. So it's just slope. So slope is in this case, it's going to be change in feet divided by the change in time. So it ends up being 3.3 feet per second. And if we're talking about this rate of change of this particle motion, of this particle, we get a positive rate. So we can say the approximated rate of change of the particle at t equals 120 is 3.3 feet per second. So this is an object that's moving. And we're tracking their velocity, then their velocity at 120 is best approximated by this slope, which is 3.3. All right, so number 17. Is the function differentiable at x equals 2? What does this word mean, differentiable? Smooth curve, right? So smooth curve. But more specifically, that means my slope what? Slope exists, which then also means that my derivative exists. Right? So if my derivative exists, that means time of 2 for both these piecewise functions, they must agree. But if it's differentiable, it's also assuming something has to happen, right? In order for the graph to be smooth, my graph also has to be continuous as well. Right. I mean, even if these two graphs are sharing the same slope at 2, you know, it could be at a jump discontinuity, then it's no longer differentiable, right? Even this is slope 2 and this is slope 2. If they're not meeting at the same point, then we can't call them continuous. Sorry, differentiable. So we have to first confirm that these actually share the same y value at 2. And if they do, then we can test to see, do they share the same slope at 2? So they must not only share the same slope, they must also share the same point. Otherwise, the graph is not going to connect and show a smooth curve. So the continuity portion means they must share the same y value at x equals 2. So I'm going to set these equal to each other and see if they actually share the same y value at x equals 2. So plug 2 in. Is that equal to I get -11, -11. These do agree, so we confirm that our function is continuous. So now let's just test their slopes or test their derivative. I'm going to just build their derivative first. If we find the limit as x approaches 2 from the left of f prime, that's going to equal to -9. And then the other side is also -9. So the slopes are in agreement, the ordered pair are in agreement. So our function is differentiable at x equals 2. So here's the slope representation here. The limit as we approach 2 from the left, that's basically are asking, find f prime of 2 from the left, f prime of 2 from the right. Are they going to be both heading towards a slope of -9? And they both are. And so we know there's going to be a smooth transition from one graph to the next, where the graph is going to still maintain that smooth curve. And then that's basically the strategy for number 18. It says what values of a and b would make the function differentiable at x equals 4. So now we want continuity without knowing what a and b are. So our strategy here is we're going to set the two expressions equal to each other to force them to be continuous. And also we're going to set their derivative equal to each other, force them to be differentiable. And then after with those two equations, we should be able to have enough information where we can solve for A and solve for B. So here's 18. We're going to set equations equal to for the continuity component of this problem. And then separately, we're going to set their derivatives equal to each other. And that's going to be the differentiable component here. So equations equal. No calculus here. We're just setting them equal and plugging 4 in for x. We can only go so far because we still have A and B unresolved. We can combine like terms, but we know we need some help from another equation if we want to get it all the way down to This is, I mean, the best I can do is combine like terms, combine my A's, but I can't really do much more beyond that. So I have to kind of wait to see what the progress for my other equation is. So my next, this is where my calculus will come in. I want these two to share the same slope at 4. So I'm going to set their derivatives equal to each other. But if I want to set their derivatives equal to each other, I first have to make sure that every term is ready for power rule, right? So a root x, I'm going to get that ready. So I'm going to make it a x to the 1/2. I'm going to get the denominator ready for the for my derivative. Okay, go ahead and find my derivative. I don't want to plug in 4 yet. I have to build the derivative first, then plug in 4, and then I can use the 2 remaining equations to help me solve for A and solve for B. So remember, treat A and B like coefficients, right? There's just some number, unknown number that's just hanging out in front of your variable. What's BX's derivative? Just B. Imagine if this is 4x. 4x will become 4. 8x will become 8. So therefore, BX will become B. Go ahead and replace every x you see with 4. Sorry, -1. So now I have both equations down to A's and B's, and now I'm just trying to use substitution to try to solve for one. We'll try to get rid of my fraction here. I'm going to multiply everything through by 4 just to make it so I don't have to deal with fractions. So I'll multiply everything through by 4. It's a little messy here, but I'm going to just put that piece in for A of the other equation. And now I'm just figuring out what A is and what B is. Okay, so I'm just taking my A equation, putting it into my A of my first continuity condition problem, and I'm just doing a bunch of calculations here to solve for B. And then once I solve for B, I can plug it into either equation to solve for A. I'm just down to substitution and trying to figure out my remaining A's and B values. Okay, any questions with 18? Okay, 19. 19 and 20, we just have to recognize that these are basically coming from the limit definitions of a derivative, and we're not having to really work the problem. It's just, can we identify the fact that they're asking about derivatives? And then once we identify what they're asking about, we can rely on our power rule to get to our answer. So for number 19, we need to recognize, oh, that's basically looking like limit definition for alternate definition. And whatever is showing up here is going to represent your function. We know it's asking for the derivative of some function at a point, and we just have to be able to figure out, okay, what function are they asking for? What slope are they asking about? And then we can just rely on our easier rules. So 19, we know the function is referring to that x squared minus 3x. That's your f of x portion. We know that it's x approaching 4, so we know that's our c value. That is what the derivative is referring to. So f prime of 4. So we can understand that's asking just for f prime of 4 for this function. Then it becomes a lot easier, right? Now you just find the derivative, plug in 4, and get your slope. But just being able to pull that information from the function, from the notation is what we really need to know for limit definition. So f prime of x is 2x minus 3, and f prime of 4 is just minus 3, which is fine. The general definition is a little bit messier, but if we understand that this is basically, the first part is basically giving you information about the function. I know the 5 plus h feels confusing, but just know that those represent the f of x plus h. So if we can just pare that down to, oh, that's just referring to 9x minus 10x squared, because and then the 5 is asking for the derivative at a point. So if we can just pick that information out from this messy limit definition, then if we understand, oh, that's just talking about this function, and it's asking about f prime of 5, then it becomes a lot easier. Okay, that's easy. Power rule, plug in 5, and we get our slope. But it doesn't matter whether it's limit definition, alternate, or general. You know that the first piece is giving you information about the function, and then the numeric value is asking about the slope. Any questions here, 19 or 20? Okay, page 4. Now I'm going to have you kind of try some of these on your own. It's just a combination of different rules that we've done, whether it's product rule or quotient rule. So page 4, number 21. Go ahead and try these. I'll go through them, but you can also check your progress in your the keys are attached. One, two, and 5. 25 to 32. Wait, 25 to 30. I don't think it's that. Okay, all right, you get that. Part A should be easily recognized as product rule. Part B is quotient rule, and part C is back to a product rule. Any questions with A or B? the last part C got cut off. It'd be negative r prime of x, and then negative r prime of -2, and that becomes -4. Any of these A, B, or C's you need me to walk through with you? Number 22, it says, where does the function have horizontal tangent? So I want you to visualize what that means. Horizontal tangent is where these points are, right? And that means this is when the slope is what? Slope is 0. And another word for slope is f prime. So we're just setting f prime equal to 0 to figure out where these graphs are actually hitting these slope zeros. So slope zeros means horizontal tangents. And after we get done walking through page 4, I'm going to have us try to do an extended or to do a derivative, find derivative for a function that looks initially messy, but ones that I just want you to use power rule for. So just a matter of doing all the algebraic cleanup, separating into individual problems, and then relying on power rule for the final step. But any questions up to 23? And 24 is just interpreting. And then 25, you're just doing slope, changing y over changing x. Finish off 24 and 25, and then copy down, or you can find space on the separate sheets or in your packet, anywhere. Go ahead and copy down number 26. It's, you guys check my work. Did any of you guys get this? So the start of this problem, you don't want to deal anything with the denominator. Just try to get that numerator to be nice and clean and separated. So careful with your order of operations. We can't distribute that 2 root x through until we get this resolved. So I decided to start off by FOILing out my parentheses squared. Careful, we do want to write that out twice. Otherwise, if you just square the 2 through, you're going to miss out on that middle term. So write it out twice, get that 3 terms to expand out. And then you can distribute the 2x to the 1/2 through. Once you distribute that through, you can start separating into individual fractions. I didn't realize, I just created this randomly. I didn't realize how many things would cancel out, but just, 5 halves minus 7 halves, which is -2/2, which is -1. 7 halves over 7 halves, it's just going to completely cancel out. I'm just left with a constant. And then 9 halves minus 7 halves is just 2/2, which is 1. So I'm just left with 2 relatively simple power rule terms. One drops out. My -1 goes to -2, and then my constant, my linear goes to a constant, and my constant goes to 0. Yeah, again, another trouble spot students have is thinking of this as x to the 1/7 or x to the 2/7, but that's actually x to the 7/2.
This looks good.
Okay, so if you look through worksheet review packet 2, that's basically what your quiz will look like, plus this problem. So this problem isn't on the quiz, but we've done one the past 2 days. So hopefully you guys are comfortable with this process. I'm going to specify a no quotient rule. So you're going to go through the process that we went through, clean everything up and rely on power rule at the end. Maybe we can finish up with practicing limit definition of a derivative, just being able to set it up. And then, but your quiz will look very much like your quiz review. I'm going to remind you to make sure you know your unit circle values. We saw that where you have to go past. If you leave your answer as cosine of pi over 3, it's not good enough. You got to go further than that and actually give me a numeric value. Oh, no, let's do this. Last minutes of class, let's see if we can recall all of our derivative rules that we need to know. So let me put that on the sheet of paper and have you guys try it. All right. Sorry. Should be tangent and secant. Your homework, which we've already done in class, just page 3 and 4 from your review packet. So I'll just come around and check that tomorrow. Um, tomorrow I'll do a help session, but only if you have like very specific or individual questions, I can go over that. I can go over the problems that you guys have. And then Thursday morning, I don't have a specific additional review for you, but we can always pick out problems to do if you want to come in Thursday morning for to do and then tomorrow we'll start our unit 3, which is We'll do chain rule and we'll do implicit. Obviously, they're not going to be on the quiz. But just kind of, give you guys some additional time to review on your own. So that I can cover new content, but then also give you some time. Just do some. Any questions? But, if we have additional time tomorrow or Wednesday, we can always I can try to pick out some more practice problems for us to work on before Thursday's quiz. Okay.
Like, I think you have this line now. Yes, but they're.
Definitely, your comments, appreciate it, thank you. Oh. I mean, okay, thank you. Yeah.